So we have the example of starting with benzene, reacting with bromine, iron tribromide, and we get bromobenzene. Okay. This goes through the activated electrophile intermediate, which looks like this, positive charge on bromine, negative charge on iron, right? So this is bromination. This is an example of electrophilic aromatic substitution. We can, of course, do the same thing with chlorine. Oops. Cl2, iron trichloride. The activated electrophile will look like this. Chlorination. Right? No difference in these two mechanisms. You're going to make the activated electrophile in step 1. You're going to have the benzene ring attack the electrophile, make a carbocation in step 2, and then you're going to do elimination to reform the aromatic ring in step 3. So far, so good. We can take benzene and react it with nitric acid, HNO3, and H2SO4. This will make a nitro group, an NO2 group. This is nitration. H2SO4 and HNO3, these combine to make NO2 plus. Right, and so NO2 plus is very reactive. There's a positive charge on nitrogen. I guess I should put my positive charge on nitrogen. Right, and so the benzene ring can come attack that nitrogen. It's a really good electrophile, all that good stuff. This is the reaction that you've done in the lab, right? So nitration adds NO2. And then let's see, what else can we do? Oh, we could do sulfonation. SO3, H2SO4. This makes SO3H plus, right? We're just adding H plus to SO3, and that makes a sulfonic acid. Sulfonation, right? So we could add a bromine, a chlorine, a nitrogen, a sulfur. We can add all of these things to our benzene rings. And I want you to notice the pattern of what these reagents look like, right? Reagents for electrophilic aromatic substitution. It's always going to be the thing you're adding, thing being added. So in this case, right, we have bromine that's being added. We have chlorine that's being added. We have our nitrogen, NO2 group that's being added. We have our SO3 group that's being added. And then you're going to add a very strong acid, right? And so H2SO4, H2SO4, iron trichloride, iron tribromide, these are all really strong acids, right? And so whenever we talk about that first step of electrophilic aromatic substitution, where we activate the electrophile, what we're talking about is we're taking the thing that we want to add, bromine Br2 in this case, and we're activating it with acid, right? So this thing, whatever we're adding, Br2 in this case, adds to the acid and makes a fantastic leaving group, makes a good electrophile, and then that goes. Right? HNO3 adds to H2SO4, right? You make H2NO3, and then you basically lose water. So minus H2O gives you NO2 plus. So we can put that here, minus H2O gives us NO2 plus. And then that's the thing that gets added. This is our activated electrophile. SO3 plus H plus gives us SO3H plus. And that's our activated electrophile when this works. So every electrophilic aromatic substitution reaction is always going to be something with strong acid, and that something is going to be activated by the strong acid to make the activated electrophile that then allows this thing to go. right? Okay, so we're going to have HNO3 and H2SO4 are going to react to give us our activated electrophile, right? We're going to end up with H2NO3. So we're just going to add H plus to HNO3. Right? And then we're going to lose H2O. So we're going to lose the hydrogen from here. We're going to make a pi bond and kick this thing out. So we're losing H2O. We're going to end up with NO2 plus. And we get something that looks like that. Now, this is a really good electrophile, and so our pi bond from our benzene ring is going to come and add to it, and that's going to give us our carbocation intermediate. Okay, so you'll get that. It's just NO2. It's a neutral compound there. That gives us our carbocation, and then to get to our final product, we're going to lose the hydrogen here. Do this E1 elimination to restore our aromatic ring and get nitrobenzene. Right, so that's going to be, here are the steps, right? Step 1, we make our activated electrophile. Step 2, we make our cation. Step 3, we go back to aromaticity. Right? So this is the general mechanism for electrophilic aromatic substitution. There's one particular type of electrophilic aromatic substitution that we're going to talk about, the Friedel-Crafts reaction. And the Friedel-Crafts reaction is just a fancy name for electrophilic aromatic substitution with carbocations. So anytime your activated electrophile is a carbocation, you're doing a Friedel-Crafts reaction. So we can start with an alkene and H+. The alkene adds to H+. We get our secondary carbocation here. And the secondary carbocation is our activated electrophile. So now our benzene ring can come attack that carbocation. Oops, got ahead of myself. And we'll get that with a cation there. And then lose H plus to give us our benzene ring back. And so now we can use a Friedel-Crafts reaction to make carbon-carbon bonds. Right? So our previous examples, we were adding heteroatoms. We added bromine, chlorine, nitrogen, sulfur, right? We added all of those things. With Friedel-Crafts, we can actually add carbons, right? So one way we can do this is take a double bond and react with H+. The most common way that Friedel-Crafts reactions work is we start with an alkyl chloride and add aluminum trichloride. So again, we have our thing that we want to add, all these carbons, and we have our strong acid. The thing that we want to add, the alkene, and we have our strong acid, right? So this is still electrophilic aromatic substitution. All this stuff kind of ends up looking the same. Chlorine adds to aluminum trichloride. We make a positive chlorine. This is now, of course, a fantastic leaving group. And so it's going to leave and make a secondary carbocation. And now we're right back where we started. Up here, we have our secondary carbocation. That's going to go through the electrophilic aromatic substitution mechanism, and we're going to get the same product out here, right? So this adds to our cation. We get this, and then you lose H plus to give yourself the final product. So Friedel-Crafts reactions, there's kind of a couple of ways you can do it. Any way that we know of generating a carbocation, if you make a carbocation, you can do a Friedel-Crafts reaction with that carbocation. We have a different way here of just making this into a fantastic leaving group so that it leaves on its own. and we make a secondary cation, and then away we go. So we make a cation, we make the non-aromatic cation, and then we eliminate to make the aromatic system. All right, so these are a couple of examples of electrophilic aromatic substitution. It gives us a list of things that we can do, right? We can add bromine, we can add chlorine, we can add nitro groups, we can add sulfonyl groups, we can add carbons, right? So we have 5 things that we can do with electrophilic aromatic substitution.